Okay. So good morning. It's time. Okay, so welcome to our first session of this IETF week. And it's ALLDISPATCH. Actually, it's a BOF, and it is an experiment and trying to see how it works if we dispatch across areas. So it would be good if you could share your feedback to our IESD and let them know what you think about this session. Thank you. So first we got this note well, and you must be familiar with it. If this is your first time, please do read through it. And there are some processes and policies you need to follow, and the IPR issues you need to be aware of, and also some guidance here you could refer to. And we also got this note really well. It's more about the behavior. And we have this IETF anti-harassment procedures. If it's more about we need to be friendly and respectful to other people's work. And if you do have any concerns, please raise them. And there is some meeting tips since we are the first session, and you could get yourself familiar with it. And please do sign into this session via the data tracker of the QR code. And so you will have your name in the blue sheet. And please use the on-site tool and when you join the queue. For the remote participants, we do have a few in this session, and please make sure your audio and video are off unless you are presenting. And your headset is strongly recommended to use. Yes, please. And here are some resources for this meeting you could refer to. Next. Okay, so this is a dispatch session. So please, for all the presenters and all the people who come to the MAC, please focus on the dispatch questions. And there are few answers to this dispatch question. I'll direct the work to an existing working group if you think there is any. I'll propose a new focused working group. And that might require a BOF, and maybe the draft is small, so that may require the AD sponsored. And further, if it's not clear yet, so more discussions will be required in the mailing list. All the work is not appropriate for IETF. Please, because we have limited time, please keep this in mind. Next. That's it.
Okay. So to add to that, we've had a number of people that have the impression that the dispatch session is for publicizing their proposal. That is not the focus here. We really want to focus on the dispatch question and just kind of describe the work that you're doing to the extent needed in order to try and answer that question. But we want to try and avoid having a lot of back and forth or discussion on the technical details of these proposals. Thank you.
Yep, we got 9 items, and so now we can start. Welcome our first presenter, the remote presenter.
Hey.
Yeah, please start.
Yeah, I'll ask the slides. Yep. So could you give me control of the slides or?
Sure.
Yes. I think now he has control.
How do I grant control?
If you drop, he can load it himself.
Or I can work with the next slide. It works as well, right?
Okay, thank you. I'm little slow on this.
No, no problem. Okay, so yeah, so hi everyone. My name is François Michel. I'm researcher at UC Louvain, and the topic of the talk here is running SSH connection over HTTP tree. So the idea is to rethink the design of the SSH protocol and run it over modern transport protocols such as QUIC, TLS, and HTTP. So SSH is quite famous, so you may know it already. The idea of SSH is to provide a set of secure services on top of an insecure network. So the set of services is like having a remote interactive shell access. You can send also execute single commands, and you can do, for instance, TCP port forwarding, which is quite extensively used as well. Next slide. So if we look at the SSH architecture, so the current version is version 2. SSH v2, the architecture is divided into 3 main protocols, so 3 main documents. The first one is the SSH transport protocol, which is handling the secure channel establishment, so key exchange and that kind of stuff, and it provides encryption. Then you have the SSH user authentication protocol, which allows you to authenticate users on top of SSH using passwords or public keys. And then you have the SSH connection protocol, which is doing the actual SSH work of spawning processes and communicating with them. Next slide. And so if you want to implement SSH, you have to implement the 3 protocols and multiplex it over a single TCP connection. Next slide. And let's say you want to like extend the cryptographic algorithms, like adding a new one. Then you typically extend the transport protocol and add new code points for new crypto algorithms. And so you update the document and then you update every implementation. Next slide. So SSH v2 is widely used, but it still has some limitations. For instance, it cannot forward UDP packets. So that means that you cannot forward quick connections, and you cannot forward some real-time protocols that are based on UDP, for instance. It can also be easily detected and blocked. So SSH typically runs on port 22, so you can simply block port 22. And if your server is running on another port, then you can simply inspect the payload of TCP packets. If you see a clear text SSH version string, then it's an SSH connection, so you can drop it. It runs over TCP, which works well, but it's subject to some small attacks like packet ingestion attacks or manipulations of the secnum. For instance, the recent Terrapin attack was about that. It was messing around with the sequence number of TCP to be able to skip some parts of the algorithm's negotiation. It's also not really well integrated with modern web infrastructures. So if you look at modern web infrastructures, you have many ways to authenticate your users. You can use SAML2, you can use OpenID Connect, for instance, or WebAuthn and passkeys. And if you want to integrate it with SSH, it can work, but you have, for instance, to deploy middlewares that keep mapping between users and public keys, or generate OpenSSH certificates to do so. So it's doable, but there is a deployment burden. And also it evolves in parallel to the web protocols such as TLS, QUIC, and HTTP. These protocols also propose a secure channel and encryption and user authentication. But it evolves in parallel with SSH. And so you have some features that are similar between the 2 protocols, such as certificates. But for instance, SSH certificates are not widely used, but HTTPS certificates are used everywhere. And so you can have cases where, for instance, you have users that deploy their VM with an HTTPS server, and simply the HTTPS server works well. It has a public certificate, but the maintainer connects to the VM using SSH, and it's not using any certificate. It relies on the trust on first use pattern. So it could use OpenSSH certificates, but it has not access to the ecosystem of X509. And so it's a bit less easy to maintain. Next slide. So that leads us to the idea here of the proposal. So the idea is to replace the transport protocol and the user authentication protocol of SSH by HTTP quick and TLS, and run the SSH connection protocol on top of it, so that next slide, you can focus on implementing the SSH connection protocol, and HTTP and quick and TLS can evolve independently and be updated. Next slide. Also, you have access to the modern features of this protocol. So you can have URL multiplexing, but also streams multiplexing, datagrams, and connection migration. Next slide. So let's see how it works in our proposal to establish a new SSH. So the proposal is called SSH3. I'll be happy to discuss renaming later. So now let's focus on the idea of the protocol itself. But how to start up an SSH2 connection. First, you do the quick handshake. Next slide. Once the handshake is established, you use HTTP. You send the HTTP extended connect method, where you can specify a protocol. Here it's SSH3. And to authenticate the user, you use the authorization header of HTTP. And so basically here you can use any kind of authentication schemes that you want with HTTP. Next slide. If it works well, if you choose a good scheme and if the user really authenticates, then you will have a 200 status code and the conversation is established and you can use quick streams and stuff. Next slide. If it does not work, then you have an unauthorized status code and then yeah, you did not succeed authentication. Next slide. So what are the opportunities of using HTTP3 here? First, you have access to the quick API. So that means stream multiplexing. You can send data on different streams and you avoid head-of-line blocking here upon packet losses. Next slide. And next slide. You also have access to datagrams. So you can do UDP port forwarding. Next slide. And you can also have connection migration so that if you change your IP address, if your user is mobile, then you can reattach the quick connection without disrupting the SSH connection, which is quite nice. Next slide. You also have quick that encrypts and authenticates all the control headers. Next slide. You have access with low effort to the X509 ecosystem quite easily. So here on the screenshot is just to show that without prototype, we just rented an Azure VM, run the server, and then using Acme generates the certificates as a classical HTTPS server, and you can access it right away without the tofu pattern. Next slide. You also have URL multiplexing. So let's say you have several VMs or containers on the same physical host. You could put a reverse proxy in front of it and do multiplexing based on the URL or based on the user or based on the SNI, for instance. Next slide. You have HTTP authentication. So with that, you can simply implement password or public key authentications that are used with SSH2. Next slide. You can also do certificate-based client authentication, but you can also do more. You can use, for instance, OpenID Connect without any middleware and stuff, which is widely used. And you can also think of maybe SAML2 or next slide, maybe WebAuthn or passkeys. Next slide. And finally, it fits well how the internet is evolving. It allows SSH to benefit from the effort of that the IETF has put during the previous years to develop the protocols such as Quick and TLS, and so it can use all these modern features. Next slide. So what about the threats? So there is one here, TCP only networks. So SSH v2 runs on top of TCP port 22. It's quite well supported on the internet. HTTP 3 runs on UDP port 443. It's less well supported, so it might be blocked by default in many networks. So there are ways to mitigate the problem. We could use TCP as well in addition to UDP by running SSH over HTTP2. There is also the recent Quick on Streams proposal, which is proposing to run Quick over TCP. That might be interesting as well. And we could also run SSH over Web Transport that supports both Quick and TCP. So it uses both for us, and so we don't have to bother too much about that. Next slide. And so yeah, that's it for me. So now I have a couple of questions for you. So is that work interesting? Does it ring a bell? If it's interesting, what would be the best outcome for the proposal? Would it be an actual SSH v3 candidate in the future? Of course, we need implementations that work well before thinking of any of that, but still, should we integrate it to another existing protocol? I know that Mask is already doing the whole UDP IP forwarding stuff, so we might think of a new Mask method such as connect shell or connect process, or maybe we could think of other designs. Is anyone interested to collaborate on the draft? I'd be happy to have any person that wants to collaborate, be a co-author, provide feedback to make it better. And is it interesting enough to integrate an existing working group or start discussions on the list or anything? So let me know. If anyone wants to implement and interpret, let me know as well. It's quite easy to implement because it's only the connection protocol to implement on top of HTTP3. So if you have access to an H3 lib with TLS or Quick, it will work well. Yep.
It's interesting enough that we have a bit of a queue to discuss. So maybe we should move on to that.
Yeah.
Okay,
Sure.
Mike Bishop.
Let's go.
Mike Bishop is first.
Mike Bishop, Akamai, editor for H3. So I like the general direction. I'm a little cautious about trying to do something on top of HTTP and then reach down into Quick. I think web transport might be the better path forward there if you're going that direction. I also kind of wonder if you still need the TCP connections when you're doing something that might already have Mask on it.
Okay, well,
but that's stuff that can be worked out later. As far as the dispatch question,
yes,
I do think that this is squarely in the IETF's remit. I don't think there's an existing working group that would contain this, so this is probably something to have a BOF on, see if there's enough impetus to spin up a working group.
thank you.
Thanks.
Mark Nottingham.
Hi, Mark Nottingham. Longtime user of SSH. Very happy to see work being put into it. I question what the utility of putting it on top of HTTP here is. Of the list of advantages that you said you were getting, almost all of them are just from using Quick, not from HTTP. And especially if things are downgraded to HTTP2 or HTTP1, which can happen because remember, HTTP is a hop by hop protocol. You don't get any of the advantages you're looking for, really. And so I think, like Mike, I would be looking at other things like web transport or other things. I don't think that's a reason not to do this. On the dispatch question, yes, this sounds great, but really question the need to go over HTTP and just at a higher level, maybe for this community, we seem to be more and more knee-jerk, oh, let's put that over HTTP. And while that's great for my job security, I think we should really think about that architecturally.
So to the dispatch question, you would point to a BOF also?
I think a BOF would be fine.
Okay, thank you.
I don't have strong opinions on the particular path.
Great. Tommy Pauly?
Hi there. Thank you for sharing this. Yeah, definitely interesting work. I think we should consider this. I think as people have been leaning towards BOF would make sense just to figure out what shape would be right. If you are doing it over HTTP, as you've suggested, you're right that it's very similar to Mask. It doesn't really fit in the charter of Mask because it's not really proxying in the same way. But if you're doing that, we should have definitely review from the community in there. We also have other things going on in the HTTP BIS working group of Connect TCP, of modern versions of also doing the similar thing. So we want review there if we're going in that direction. But I think also the points about web transport are interesting. So let's have a BOF and try to maybe talk about all the different ways you could spell this and figure out which one makes most sense.
Sounds good. We're going to need to close the queue if I can figure out how to do that, but David Skenazy is next.
Hi, David Skenazy, putting stuff over HTTP enthusiast. I'm really excited by this work. I actually see good reasons to put it over HTTP personally. We run SSH through our load balancer internally with Connect, and this could be much better. But specifically to the dispatch question, I think this is large enough to warrant its own working group. So I would be very supportive of a BOF.
Thank you. Christopher Allen.
Yeah, so I share some of the questions of everything over HTTP. Although I think it's not unreasonable, but I also feel like we've kind of waved our hands at the SSH auth side of things, and I just have a lot of questions about using the same keys for SSH developer usage in some of the peer-to-peer things that are natural and easy with SSH that are hard with HTTPS. So I'd like to see this as a BOF, but I would like to also either know that this is only going to be focusing on transport and sort of making a better layering for authentication, or that they're also going to be looking at the larger problems of auth and key usage and all of that. Thank you.
Great, thank you. Ecker, next.
Hi, Eric Squirla. So, you're definitely singing my song about having one transport that's good. And I think if we were designing SSH from scratch, this would clearly be something along this angle would clearly be right. The problem is we're not designing SSH from scratch. There's a huge deployed base of SSH. And so I think the threshold question, and so I agree with people who said that there should be a BOF if we're going to do this. But I think the threshold question for that BOF ought to be, are any people who are currently deploying SSH at scale, including the big SSH clients, interested in doing this? Because if they're not, then IETF producing something that says you do SSH over quick is kind of not going to get very far. So I think that the ISG should determine prior to proving this BOF whether or not that is in fact the case. Because having a BOF when no one wants to do it is silly. So if people want to do it, then fantastic. But if people don't, then we probably should not. Okay, Martin, thank you.
Thank you. I mean, this seems to be pointing pretty clearly toward a BOF. We do have 3 more people in the queue, so and we're about out of time. But please go very quickly, Alex.
Hi, I'm Alex Shanowski, Google. I'm also one of the maintainers of Mosh, which is, I think, the first use of an SSH-like thing over UDP. And I want to say that I'm very excited in having this work move forward. There's a bunch of feature requests in Mosh that would be solved by this work, by people basically wanting the benefits of UDP transport along with the reliable streams of TCP. So I think definitely we need to move forward on this. I have lots of evidence that users want this and would deploy this, including Google internally users of Mosh. So I definitely want to see this move forward. I think a BOF is fine. I also think Mask is fine, but we definitely would need to do a recharter. I think that the question of why not quick is absolutely answered by the Mosh precedent. We need the TCP callback. We need all these things to work well.
Okay, thank you. Richard Barnes.
Hi, Richard Barnes. Just a quick meta question. I think BOF is the obvious answer, +1 on that. I just hate it every time we dispatch something to a BOF that takes another 3 months and we waste all that time. So I'm looking over at the various ADs, let's please keep this moving and have a virtual BOF in between the IETFs.
Sounds good. Thank you. Martin Thompson.
Yeah, Martin Thompson. I think Christopher mentioned this, but I think the question of do we do transport or do we do transport and all the various authentication options might turn into a bit of an attractive nuisance. So I suggest that some work be done ahead of any BOF on refining the scope a little bit so it's very clear what any working group might be working on. Because I think the plethora of options that were presented to us is likely to cause failure more than success.
Okay, thank you. So I think the strong consensus here is for a BOF. Thank you very much. And we'll move on to the next presentation. I neglected to acknowledge our 3rd chair that's remote, Rafat, who is here also and contributed a lot to this, and also to our other chairs that aren't listed, which are Daniel Gilmore and Martin Vigoureux. So thank you to all of them. So next presentation is Andrea Vesco.
Yes, do you hear me?
Yes, we can.
Hello, everybody. So I'm going to present preliminary work I prepared with my colleague Leonardo Perugini on the use of the verifiable credential as a new credential type for authentication in transport layer security. Next slide, please. Okay, just to set the ground, verifiable credential is one of the components of the self-sovereign identity, that is a decentralized model for digital identity in which, of course, the entities have control over the information they use to prove who they are. And the identity in this model consists of three main components. Of course, a keeper, a decentralized identifier that is a URI to essentially an address to DLT where the public key is stored, and at least a verifiable credential that also contain a link to the DID of the identity. And both VC and DID have their full specification in W3C, and of course they are evolving. Next slide, please. Again, just to set the ground, an entity that want to build his own self-sovereign identity start with creating his public key and secret key, the keeper, then is going to store the public key.
Uh-oh, he froze.
Froze out here too.
Yeah, frozen remote.
Andrea, are you back? We don't have any audio from you now.
Click the presenter. He's off now.
Okay, well, I think we're going to move on then, and hopefully Andrea can get his connectivity issues resolved, and we'll come back to that.
Okay. Do you hear me now?
We hear you now.
Okay, so sorry for that.
Okay, good.
I received some.
Please continue then.
Yeah, sorry for that. So we were at the point an entity stored the public key on the DLT, and then at that point can request a verifiable credential to one of the issuers in the system. At that point, the entity can authenticate with a verifier to get access to service and resources. Next slide, please. And how this authentication works today, essentially, this authentication occurs at the application layer for the client side. So
Uh-oh. Happened again. That's unfortunate. In any case, while we're waiting, Christopher Allen, why don't you go ahead and...
Yeah, so this hits a lot of my keywords. Go ahead, is he back? No, okay. Anyhow, there is a SPICE charter being circulated for a BOF, which is talking about verifiable credentials. There's lots of stuff going on in the DID, verifiable credential world, and the W3C that doesn't map to the IETF very well. I really want to see some stuff here to resolve some of these things. I'll even admit, even though I'm an invited expert and co-author of the DID spec and W3C verifiable credential spec, that doesn't work with HPKE, doesn't work with some other IETF patterns, et cetera. That this is the beginning of a big important pile. How to untangle it. So I just wanted to throw that out as a that this is an important topic, but don't know how to do it.
So toward the dispatch question, how would you presume that IETF should take this up?
I don't know if it's, maybe it's BOF. I'm not sure. It just feels like BOF usually has more of a charter before you do a BOF, and this feels like this maybe really needs to be multiple BOFs. I don't know. I don't know what is pro BOF.
Yeah, there are different sorts of BOFs. Okay, thank you. Andrea, you're back?
Yes.
Okay. Did you want to continue, or we've got several people in the
Yeah,
queue?
we can go home just to the next slides, and we can arrive to the point is that essentially when you have the in specific domain like the IoT domain, the use of X509 certificate is not straightforward, and in these scenarios use SSI can be a very good idea. For many, there are many pros, just as some example, the endpoint can update, rotate its keeper without the need of refreshing the VC. The endpoint can also revoke immediately its DID and the identity. So in this domain, the idea of using SSI can be a good idea. And so if we have this kind of identity, why not to do authentication directly at the TLS layer? And this is exactly the topic of our ID. Next slides. And what we are proposing essentially to add a new certificate type called VC in addition to X509 and raw public key in the existing client certificate type and server certificate type extension. Add just a new extension called DID methods that the endpoint use to transmit the list of DID methods supported by the endpoint to resolve the DID of the peer. And in case certificate type is selected, in this case, the certificate message will carry, of course, the content of the VC inside the message. Next slide, please. This is just an example of a full TLS and shake with the verifiable credential where the client proposed to use verifiable credential of X509 in server certificate type and client certificate type, and then inform the server about the DID match that he can use to resolve the DID of the server, and the server can then select, in this example, for example, the verifiable credential to proceed with the authentication. With this very simple extension and simple use of the server certificate type and client certificate type, we can also have hybrid and shake. So next slide, please.
Okay, I think we're getting enough detail here that we have several people in the queue with opinions about dispatching this. So can you wrap up?
You can go to the last slide. Sorry, the previous one. So what we have already learned during the previous IETF. First of all, the TLS working group say that application or domain-specific extension to TLS are out of scope, and we perfectly understand the reason behind this. The working group usually only consider extension to protocols that are widely applicable, while at the same, in this case, we are targeting the IoT domain. We also have some discussion with the Utah working group. There is a possible interest there, but of course, the extension are out of scope. And so we are here just to listen to your suggestion. If, first of all, you are interested in this kind of work, and what are the possible venue to continue discussing the idea. And thank you very much, and sorry for the disconnections.
Okay, thank you. We're going to close the queue pretty quickly, so if you have something to say about it, please join the queue. Hannes, go ahead.
Hi. For defining or adding a new value to this registry that defines these certificate types, which this proposal does, you only need a specification, and ideally that specification should be done in an organization that actually works on these verifiable credentials. So I would just do that in the W3C, write the specification alongside of the group who, I'm not a W3C expert, who already works on these verifiable credentials and does the work there. If someone does something similar for things like CWD and JWDs, as it would be, for example, in SPICE, then clearly there is a potential home there, but it was not proposed there and was not discussed, so purely speculation. It looks pretty straightforward to me, just add a entry to that registry and done.
Okay, thank you. Ecker?
I changed microphones, so we'll see if this one's any less terrible.
Sounds good.
Good. Okay. As Hannes indicates, if all you need is a code point, then we don't need then you don't need to do anything in TLS, because all you need to do is along the specification you can render one. Well, I can't help too loud, so I'm going to have to fix that separately. However, there really is only one place in IETF right now this could go to, which is TLS, which is the only place that's like really empowered, like make new code points for TLS other than just doing it yourself. I think probably the answer here is to bring, and I'm also somewhat concerned due to some questions in the chat about whether or not the binding to TLS is actually as straightforward as people seem to think it is. And so I think this really does have to go to TLS, and then if there's no interest, then you should just register it yourself.
Okay, thank you. Richard Barnes.
I am Richard Barnes. I would like to dispatch this to the future. I think that like Eric and Hannes are totally right that the place this should ultimately end up is in TLS or as a private registration. But I think the VC space is just too unsettled right now to do things in the IETF. There's a bunch of multiply defined, non-interoperable stuff, and we just need some time for the space to settle down and get some deployment first before we start defining these code points. Once that settling down has happened, I think it'll be straightforward, as Ecker and Hannes pointed out, and we'll just do it in TLS and it'll go. So if we're going to dispatch it somewhere today, send it to TLS, but I think we should hold off a little bit before we do that.
Okay, thank you. Wes.
Thanks, Wes Hardiker, ISI. I'm not quite sure exactly where it should go. I kind of like the future idea, and specifically wherever it ends up, I think that there are multiple sort of spaces that are working on this now. As one of the chairs of the dance working group, it's an example of there is some overlap in the solution space. So it would be good to see a comparison of why you're not following any of the existing work in various places, and how can it be married, or what is different and things like that, in order to get a decent evaluation.
Okay, thank you. So I think my reading of the room is roughly that this goes to TLS if it's in fact ready to come to IETF at all. Okay, thank you. Next presentation is Happy Eyeballs version 3 with Tommy Pauly.
Can I get slide permission?
Yeah, if we can figure out how to grant, if you can do that.
Can I do it?
Yeah, you need to go to the icon.
Grant preload. Okay, that's it.
No?
You got it?
Okay, well.
You need to join the.
All right, I'll just say next slide. Hi, I'm Tommy Pauly from Apple, and I'm going to be co-presenting with Nidhi Jaju, who is on the Google Chrome team, and she's remote. So I'll just give a brief introduction to Happy Eyeballs as it exists, and then Nidhi will take us through why we need a new version and the questions about where this should go. Next slide, please. All right, so Happy Eyeballs, it's a funny name if you haven't heard of it before. This is an algorithm on the client that the reason for the name is that it's trying to make the user's eyeballs happy when they're loading a web page in a browser or doing some other type of interaction by making the connections work quickly and get to servers that are actually working. Next slide, please. So the context here is this came from handling the transition from IPv4 to IPv6 on various networks. And it's based on the assumption that IPv6 is the more desirable option that you want to use. And it's a way of racing different options you have. One of the main reasons to prefer IPv6 actually is that it does perform better for clients. So next slide. There are a couple different reasons here. It's not necessarily intuitive, but because we are going through fewer NATs on various networks, that ends up being a better experience for clients. We also have, we see a strong correlation between v6 routes and having more optimized servers and better server locations. And so it actually makes the experience better. We have better routing, but also v6 is, the future that has been coming for a very long time. So we want to use it. Next slide, please. But of course, we can't always use IPv6 even if it's available, because sometimes it's broken. And that was the whole reason for motivating Happy Eyeballs in the first place. Next slide, please. So there are various things that can go wrong. Servers can essentially be available on v6, but be broken or slow. Networks can offer you v6 connectivity, but they may have middle boxes that slow things down or actually break connectivity. But one of the insights that we get from Happy Eyeballs overall is that choosing just one address and trying to make a connection to that and waiting before you ever try anything else that you have as an option is a bad idea. You're more likely to run into an issue. And this actually extends to things beyond just which IP address you want to connect to of a server, but all of the other options you have. Banking on just one option working doesn't work very well. Next slide. So I'm briefly going to go over what the V2 algorithm is. So it essentially has 3 stages. We do DNS queries asynchronously, we sort the addresses, and then we race connections. Next slide. So I won't go into detail here, but essentially clients will do DNS queries to figure out what available addresses they have. In quadding, they do this all in parallel, and they have an algorithm for how to wait for the answers to come back. Next slide. The next step is that we do sorting. There are existing RFCs on this, but we also use historical information and add a preference for IPv6 at the front. Next slide. And then finally, this is one of the key parts. Happy Eyeballs is about racing connections. And so there are different connection attempts going on in parallel, but they're not all at the exact same time. They are a staggered parallel race where you choose your most preferred option, then you choose the next preferred option after a delay that's based on the round trip time of the network. Next slide. You can look at this in detail. These are some numbers that we've shared before in MapRG and other venues. But overall, we find that Happy Eyeballs does a great job of helping us use v6 when it is available, and when you have networks, and when you have dual stack hosts available. But we also see that even when all the stars otherwise align, a stack that's doing Happy Eyeballs v2 will end up using v4 around like 7% of the time globally. So we do still see brokenness out there. So it still matters to do this. Next slide, please. As a sidebar, there's some discussion that's happened around Happy Eyeballs that doing this type of racing can hide brokenness in middle boxes, etc. We believe that's something that doesn't belong in the core algorithm document, but is something that should be addressed and discussed somewhere within the IETF about how can we do better reporting for errors. Next slide. All right, so that takes us to why do we need a new version? So Nidhi, go ahead.
Yeah, so I'll talk about version 3 of the algorithm. Next slide, please. So why do we need a new version? So there have been lots of changes to DNS and transports in the IETF space since version 2 was published in 2017, including this new protocol that you might have heard about called QUIC, which was standardized 3 years ago, and more widespread use of it, increasing deployment of IPv6 only networks, standardization of new types of DNS responses in the form of SVCB and HTTPS resource records last year that provide information like address hints, service priorities, and supported protocols, and encrypted client hello or ECH, which is being worked on in the TLS working group. Next slide, please. So the updated algorithm follows the same overall phases as the previous version, as Tommy talked about earlier. Next slide. However, there are slight tweaks to incorporate the new additions, which are bolded. So when we asynchronously query DNS, we now query for SVCB records in addition to the quad A and A records, placing SVCB-based responses first, since they provide better hints about address families, ECH, priority, and protocol support. There's some additional considerations to incorporate and prioritize SVCB-based responses in the rest of this section as well. Next slide. So the sorting algorithm for the addresses stays mostly the same, except for the addition of ECH keys, SVCB priorities, and ALPNs if they're present, and we prioritize these ahead of the other criteria to maintain security while respecting priority signals and protocol preferences. Next slide. And finally, when making a connection, the previous version raised attempts until the TCP handshake completed, but this meant that we might have ended up with a broken or slow TLS handshake, where another attempt might have succeeded sooner. In the updated algorithm, we raise connection attempts until the full handshake completes, whether that's TLS over TCP or QUIC. Next slide. So there's a lot more detail on this slide, which I won't get into now, but as you've seen, we're generalizing the algorithm to prefer QUIC capable endpoints due to the benefits that QUIC provides, including improved delivery, congestion control, and connection migration. Next slide. We also included several considerations based on ECH to maintain security. We still have some open questions regarding what's reasonable in this area based on clients being SVCB optional or reliant, and when it's okay to start a TCP handshake or send a client hello. Next slide. So this brings us to the dispatch question. Where does this work belong? We started with v6 ops at the last IETF, as that's where the first two versions of Happy Eyeballs were developed. However, as you've seen, there are many areas that are involved in this version of the algorithm, which we'd like reviews from, including IPv6, DNS, QUIC, HTTP, and TLS. Some options that have been suggested are continuing in v6 ops with reviews from other groups, moving to TSVWG as it's a more general transport group, or forming a new working group in WIT area, focusing on client algorithms and operations. So we'd love any feedback about the best place for this work. Thank you.
Okay, thank you. And we have a queue starting. Bob Hinden first.
Hi, Bob Hinden. I support this work. I think it's important. I don't have a strong preference whether it's in v6 ops or TSV working group, but I think we should do it, and it should get dispatched somewhere.
Lorenzo Coliti. I also support this work. I think it should not go to v6 ops. I think while it while it grew out of v6 ops, it solves a plethora of other problems and has a variety of hard to predict implications. Like racing stuff that's security sensitive potentially is something that v6 ops is really not qualified to talk about, right? And racing QUIC against HTTP, what are the consequences for? I mean, I feel that it belongs in some sort of transport working group. So yeah, not in v6 ops. That working group should also carefully consider, again, these consequences. And I would also caution us to keep in mind that the performance advantages obtained by this protocol and the fact, for example, that it uses IPv4 some percentage of the time may not be because it chooses the best path. It may be because it's just reacting to random packet loss, which could cause, the second backup attempts to be preferred just because, right? So I think that is something that really sort of the transport folks are, I think, most qualified to talk about. And yeah, this isn't, not, I think the position of saying, oh yeah, this is, you always need to race is a bit simplistic. The other position of saying, oh yeah, well v6 works, you can only try one address is also simplistic. But again, transport is the working group that is most qualified, I think.
Thank you. Okay, Jen.
Yeah, Jen Linkova. Thank you very much. I just read the draft again. I really like the changes you've made. I even sent you some comments because I got confused with your GitHub process. So I sent you just an email. Anyway, I think this definitely should be done, right? Regarding groups, I understand Lorenzo's concerns, but I also see a lot of things which do belong to v6 ops. So maybe you really need a different working group or some place when all interested people come together and work. And I do not think it really matters which room those people are sitting. But for example, one very important thing I think we need to discuss is what happens when you have a dual stack device on a network with DNS 6.4. Do you want that to prefer synthesized records and go through the NAT 6.4, or you want them to prefer native IPv4? Right? This is something, it's a fundamental question, right? Do we want those dual stack devices still use v4 natively or fake v6, right? I don't know the answer. I think it's something we shall discuss.
All right, Ted.
Ted Hardy, I think the dispatch question here is best answered by a new working group. It seems that there's a good bit of overlap, but it's overlap in different working groups and in different areas. And the only way to really bring that together is to get a new working group and assign advisors from the appropriate areas and encourage people to join it. Thanks very much.
Thank you. Hey, Rolf.
Rolf here, Akamai. Thanks for this. I mean, I certainly would like to work on that, and I think it belongs somewhere in the IETF. Don't have a particularly strong preference, but as Ted said, there are multiple kind of avenues that are pursued here, so maybe a new working group is a good idea.
Okay, and Pete.
Pete Resnick, just to voice what was discussed in the chat room. A short recharter for TAPS might be interesting. You know, I think the comment that transport people need to be in on this discussion is exactly right. Somewhere in that area would be fine. Doesn't matter whose charter you add it to, or as Ted said, a new working group, maybe one of these short, you know, quick working groups with single topic is fine, but something that gets this done quick would be good.
And since we've got time, Warren, go ahead.
Thanks. It's not actually related to this. Warren Kamari, Knockmonkey. Could whoever's got the access point code ZTP_435119 please turn it off? It's using 160 megahertz and it's over there somewhere and it's killing the wireless.
Okay. Thank you.
Yeah. Okay, so we lock the queue and we hear support and interest for sure for this work. And some clear comments is not V6 ops. And we hear more about the support to have a new working group. That working group might cross areas, so we need experts. But for sure, the transport area needs to be there. Yeah. So
The WIT area now. Yeah, cool.
okay.
Thank you. All right.
Thank you. So our next speaker. Oh, you want me to? No.
Okay, David Weekly is next.
Hang on, life second. Warren wasn't joking. So somebody here has a travel Wi-Fi access point that is screaming louder than all the IETF access points, and which is why this whole section of the room has no Wi-Fi. So if you have a CTE travel Wi-Fi box, please do turn it off.
Do it.
Hey, folks, people can hear me all right?
Yes. Yes, please.
Sweet. All right. So, hey, everybody, this is my very first IETF. I'm really excited to be here, or at least here online. I wish I could be with you there in Australia. While I've worked at places like Google, Facebook, and now Capital One, I'm here presenting without affiliation to any of those institutions. My personal opinion is that email misdelivery is an actual and not hypothetical problem. It unintentionally happens to nearly all of us. This proposal addresses a real problem that has existed for 45 years in email. There's a clear analogy to postal mail handling, and all involved parties benefit from having a standards-based approach to resolving the problem. Next slide, please. So here is a real non-theoretical problem. What can recipients do about misdirected email? What you see on the right is an actual email I got in late December. I get maybe one of these a week, sometimes for a Diane weekly, sometimes for a Jeffrey, sometimes for a Doug. Some would argue that I should just mark the email as spam because it's the sender's responsibility to ensure that emails are sent to the intended party and should be double opt-inning a user to make sure that they only send email to the intended recipient for a given account. While there's a grain of truth to that, there's also flows that make it much more challenging to verify an account holder's correct email address, such as if a user wrote an email address on a sheet of paper for sign up or faxed it in, and yes, that's still a thing, or a representative took the email address over the phone. Now, in this situation, the sender is legitimate and otherwise has proper mail sending hygiene with correct ARC, DMARC, SPF, and DKIM. But what it doesn't have is either an unsubscribe link or one-click unsubscribe because it's not a subscription list. I have no standard way to tell the sender that they've got the wrong person for this account. And I really would rather not spend an hour on the phone with the sender to try and get them to update their records. It would be nice if there were, like one-click unsubscribe, a simple way to just tell my mail client to tell the sender that they got the wrong guy. Next slide, please. So postal mail solved this about 100 years ago. You probably get misdirected postal mail all the time. The post office knows this as part of the definition of first-class mail, that they'll transit the letter back to the sender if there is an issue with delivery. And one of the issues with delivery is there's no such person at the address. So you bounce the letter back to the sender, and hopefully that kicks off a process whereby the sender can attempt to find a better address for the recipient or another way to get in touch with them, like a phone number. Next slide, please. So the question is this: what if email had a wrong recipient notification? It would need to be user initiated via the UI. This wasn't meant for me. It would probably need to only show this if the UI was confident that it wasn't spam, that the message wasn't spam. This is mostly for a B2C, where you often see email addresses of the sender as no reply at. If a human writes to you and it's misdirected, you can just write back to them like, hey, you sent this to the wrong person. What I like about a proposal that gives a wrong recipient notification is that this benefits the wrong recipient, who will in theory no longer get the emails not intended for them. It'll benefit the sender because they might accidentally be transmitting PII to a third party, and it benefits the correct recipient because they finally actually get the email that was intended for them. Next slide, please. So let's say we craft some sort of a return path for misdirected emails. We could call this a wrong recipient flow. So what? What is this option? What options does the sender have if they get one of these notifications? The first is that it's likely that they have the wrong email address for the user. So they should make a best effort to try and connect with the user via some other channel to verify a correct email address. They could use a phone call, a text message, postal mail, email to prior addresses used, send a push notification if the user has their app installed, or even show a message in the app or web experience that they need to update and confirm their new email address. And they may want to stop sending emails to that known bad address for the account. Note that this is different than a do not email indication. The user may have a separate relationship with the sender for a different account that is correct. Of course, and as noted earlier, if the sender validates the email address mapping to an account, this will mostly be avoided. Next slide, please. Cool. So if we think that email should have the same no such recipient capability as postal mail has had for centuries, what are some ways that we could implement this? My thought was to mirror the wild success that has been seen in RFC 8058 deployment. In only a few years, it has so vigorously become best practice that the major mailers this quarter are going to stop carrying non-8058 compliant bulk email. Just like 8058, my proposal has a simple post to a sender provided and sender validated URI, with the client never sending any cookies with the request. For offline use or SMTP only MUAs, the standard could support using a mail to URI. Much in the standard has been drafted with an explicit intent of being a close cousin to 8058. Indeed, one of the 8058 authors has been helping me with the proposal. Next slide. So here is the proposal. It's actually, in its essence, completely contained in this page. There's a header that senders include for wrong recipient notifications, and there's a post to that address by a mail client when the user indicates that an email has been misdelivered. That's it. You'll notice here a signed URL, but there's explicitly not included in the standard a strict recommendation on how to sign the URL, since it's only the sender who needs to be able to validate it. The client just blindly posts to the provided URL after the user action with the fixed post body and nothing else. Next slide. That's it. Thank you so much. I really appreciate your attention. I'd love to know how we can dispatch this best.
Okay, Tobias first.
Okay, Tobias Flag, are you here?
So Tobias Siebig, Max Planck Institute for Informatics. So I personally am not sure whether this draft is just adding another version of NDR. I mean, you mentioned NDRs, but technically it's just encoding a user interface thing based on NDRs, because technically we would just send an NDR to the return path and people would just be required to actually do some kind of handling for return path emails, which, I mean, if operators like ESPs would pick that up, that might actually also have other benefits.
So your answer to the dispatch?
I'm actually not sure whether we have something for that at the moment.
Okay, thank you. John?
Thanks. Does my audio work?
Yes.
Yep, I got you.
Yeah, I'm the author of 8058 that he referred to. And indeed, the one-click unsubscribe has been successful enough, excuse me, that many large mail systems now mandate it for bulk mail. And having talked to some of them at MOG, I think they're interested in this too. So I think we should do it. I think the obvious place to dispatch it is assuming the mail maintenance working group gets spun up in the next month or two, which seems likely it should go there.
Thank you. Brown?
Sorry, busy taking notes. Yes, I definitely think Mailmate is the right place to dispatch this. I think it is one of many things. There's been discussion of a more general trust and safety response. Say this message is something I subscribe to and don't want, which is the list unsubscribe version, but also this is something I didn't subscribe to, is something that you might want to say back, or say there's something else wrong with this message. And so a more general feedback than just adding a new header for each new case we come up with, and having a general feedback and then a defined set of things you can say, well, the problem with this message in the post body is we probably want to solve more than just this one problem at once with this and extend list unsubscribe. Just on the previous dispatch as well, there was a thing in the chat that said that we should dispatch it to every working group and see which one takes the work for happy eyeballs. Just wanted to throw that out there.
Happy
Okay,
drafts.
Christopher?
Yeah, so I like this. I think having it go to mail maintenance isn't a bad idea, but to a certain extent, this is simple. It's following a successful pattern with 8058. Can we just send it to an area director to basically do one of the expedited RFC things, or at least an informational draft, so that people can start saying, yeah, that's good enough. We're already implementing 8058. We'll implement this as well, rather than waiting 6, 9 months, a year, or whatever for this to go through a working group that doesn't exist.
Funny you should mention the area director.
This is Murray, the area director you're talking to. I think that the right way to do this is to send it to Mailmate, which is currently in the process of hacking out its charter before it should hit the next telechat on 4.4. So it's probably going to go that way. I have no interest in sponsoring another document, especially since there's a working group coming that is in which this falls very clearly.
Scott Fleur. Scott Fleur, Cisco Systems. I would not want to have it rush forward because there may be some security implications about allowing somebody to send this arbitrarily unauthenticated wrong email address. It needs to be thought through. A working group would be fine. I wouldn't go through an area director directly. Thank you.
Okay, thank you. So. And we hear support. And so maybe more discussions in the mail maintenance working group to have more feedback. And also we have suggestions to share it in more areas and to get more feedback. Okay, so next is a remote presenter.
Shannon, are you on the call?
Yep, right here.
Great.
And Christopher Allen will be joining for any comments, questions, etc. So my name is Shannon Appelkline. I'm with Blockchain Commons. We're working on creating infrastructure that's open, interoperable, secure, and compassionate. Next slide. So data is the heart of the internet, but still the Wild West. There's few controls on how it's shared or reshared. Data privacy is all or nothing. Once data is breached, it's out there. It's being shared with little concern for human rights. We need to make the internet more humane. Next slide. So we have three challenges. The first issue is that data is not minimized. Most interactions involve more data than is needed, even in the face of regulations such as the GDPR. Next slide. That becomes even more problematic when data gets out there. You can combine one batch of excessive data with another, and suddenly you know a lot about the data's subject. Next slide. Worse, when you have lots of data, you can use it in ways totally orthogonal to what was originally intended. You might have given your address to receive a shipment of vinyl records, but when that gets correlated with the financial data you provided to your bank as KYC, suddenly the burglars are knocking at your door, or rather pry barring your window. Next slide. These challenges are all cumulative. More data disclosed means more data correlated, means more secondary use, means more problems. Next slide. Worse, the amount of data being collected, it's growing every year. It's more sensitive and it's more often placed online. We show some activity trackers here. I have one on my wrist. They're a great example. They can record where you are and to a certain extent what you're doing. How can we protect data that sensitive? Next slide. Digital identity is the next big frontier. It's really coming of age right now with DIDs, MDLs, IDIS, but it's been around for a while. I shockingly discovered I have 410 online accounts that contain a lot of personally identifiable information. If that's all correlated, everything about me is out there. Next slide. Honestly, though, identity, credentials, healthcare, they're just the tip of the digital iceberg. How much information could a competitor gain if they accessed shipping records? How much espionage could a foreign country commit if they tracked the executive office's Fitbits? How much trouble could hackers cause if they broke the chain of identity and software releases? We need to get in front of this now. Next slide. So IETF has some solutions, RFC 6973 and 8280, which talk about privacy and human rights considerations. Next slide. 6973 talks about privacy in the design of internet protocols. Next slide. 828 expands that with a look at human rights considerations such as open, secure, and reliable connectivity. Next slide. Unfortunately, these RFCs are not enough because they're not concrete, and more importantly, because they're just considerations. They're not required. They're not being used. Even if they were, new privacy innovations and requirements have appeared in the last decade. The RFCs are dated. Next slide. For example, take a look at 6973. Its first three recommendations for privacy are to incorporate anonymity, pseudonymity, and data minimization. Next slide.
Shannon, excuse me, and you got a lot of slides, and so please focus on the dispatch question.
Yep. We're going to get to what we're doing and then what are questions very quickly here. So Bitcoin's an example of why pseudonymity isn't enough. I mean, we've seen you can track information through it. Next slide. Meanwhile, data minimization, though it's definitely a foundational requirement, it causes problems with some of the human rights needs in RFC 8280. Next slide. So there are some cutting-edge technologies like zero-knowledge proofs, for instance, BBS proofs, which can deal with this. Next slide. But we need privacy tech that's simple, well understood, and in production, but still more advanced than 2013. Next slide. We need a middle ground. Next slide. So that's where we come to our solution, which is deterministic hash data elision. It's that middle ground. Next slide. Deterministic means the data is always stored in the same way. Next slide. Hashed means that a cryptographic hash is created for each element of data. Next slide. Next. And elision means that the data can be removed, and in particular, we want the data to be removable by any holder of the data, not just the subject or the issuer. Next slide. So the format we've been using for this with working code is a Merkle tree. There's other options. Next slide. In a Merkle tree, leaves hash the data of their branch, nodes hash the hashes beneath them, and a root hash, which is what you're seeing at the top here, verifies the entire structure. Next slide. When you lead data, you remove one or more branches, but the hashes remain validating the integrity of the data. Next slide. So what you do is you sign the root hash, and then you can have authenticity even when material is deleted. Next slide. So here's some of the core advantages. Any holder of the data can choose to elide data at any time. That supports data minimization because it's suddenly easy to exclude information, but the signatures, as I said, remain valid. Next slide. A hash data elision system can go much further. Inclusion proofs mean that you can elide parts of a tree and then give proofs leading to the elided hashes, which allow for the verification of data even when it's not there. Herd privacy takes the next step. You can publish only a root hash and give out inclusion proofs to data blocks, allowing individuals to reveal that data or not as they see fit. Next slide. I spoke earlier of the dangers of correlation, but it's actually not all black and white. Sometimes you want to correlate, sometimes not. An advantage of deterministic hash data elision is that it allows you to match the requirements of your data set by choosing a hashed method that either supports or hinders correlation as you prefer. Next slide. For the IETF, the advantages are it supports these two RFCs, and in particular, it supports the authenticity, decentralization, and integrity from the human rights RFC that were kind of left out if you do core data minimization. Next slide. So we think it's important because it can cover a whole lot of areas: credentials, data provenance, etc. Next slide. So we'd love to see support for any version of deterministic hash data elision, but we have one called Guardian Envelope. It includes all of the fundamentals that we discussed already. It's built on a Merkle tree, and it also does additional things like encryption, operational functions, other cryptographic data, and lots more. We have a full working prototype of it in a reference CLI. Next slide. Okay, here's our questions. Next slide. Most generally, how can we advance this sort of issue? It feels like there's not a good venue, but we have three specific things. Next slide. First, we feel like these two RFCs have been largely ignored. So how can we do better on this? In a recent working group charter, we heard there just wasn't a lot of support for these RFCs. How do we improve respect for what we've heard called core IETF values? Next slide. Specifically on data minimization, how should we create a group for it? Should it be CFRG? Should we run a BOF? Should we join another group? And next slide. More specifically for Guardian Envelope, our specific implementation of this, we did great work with the CBOR group on it, but they ultimately said they weren't the right venue. Some say we should try and work with COSE, but they do have legacy constraints. So do we form a working group here? Do we take it to an area director, or do we do a BOF here? Next slide. If you want more info, these are our two drafts. Appelkline hash elision is this problem statement, and McNally envelope is the write-up of our envelope. Next slide. Next slide. Thank you. And this is contact info for myself and Christopher.
Okay, thank you. Paul Hoffman.
You gave a list of, the chairs gave a list of possible dispatches at the beginning of the meeting. I think this goes into a different place, which is the IRSG. There is, I've read or have skimmed over carefully the two drafts. There's a lot of statements in there about this will cause that, that you'll get certain features and such like that, that are far outside the protocol space. I would propose this would be something that is very strongly research, and it's not just cryptography. So I would say it would be somewhere in the IRSG I'm sorry, in the IRTF, and would interact with CFRG, but not be in CFRG. Thank you.
Tobias.
Yeah, so Tobias Vivek, MPI Inf, and I would actually second that. So HRPC maybe might actually be the most fitting place.
Okay, thank you. Ecker?
Yeah, so I think you've asked a number of dispatch questions. I guess to answer the initial one, those documents you're citing were not produced by the IETF, and so the fact that they're being not like widely implemented by IETF might be partly due to that. There are a number of places to discuss things like this, as people suggested, perhaps somewhere in IRTF, though I don't think HRPC is probably the right place since it's not really doing anything meaningful in terms of protocol specification. This is a technology other people might use. And so in terms of dispatching it in terms of IETF work, I think the threshold question, as I sort of said earlier, is, does anybody in the IETF want to use this for something? And if the answer is no, then it gets kind of dispatched to dev null. So, I certainly don't think it should be dispatched to any IETF work right now. And I think that like the next time you present this, what you should be asking is to demonstrated desire for people in IETF to want to use this technology.
Okay, thank you. We're going to need to close the queue. We just did. And so, Michael.
Yeah, thanks so much. Yeah, appreciate this. I will strongly concur with maybe IRTF for some of this. I'm not 100% sure exactly what was being proposed there. It seemed like a whole bunch of different related things. Maybe there were some technical drafts as well that I know have bounced to COSE and CBOR, and feedback's been given back on that, right? So maybe let's complete the work already in progress at COSE and CBOR that has some relation, and then go from there and see, once again, to Ecker's point, if there's follow-on tech that someone at IETF wants to use, maybe we carry those pieces into IETF very explicitly with 1 or 2 slides, not 41 related to a broad problem statement. So thanks.
David Skenazy.
David Skenazy, Internet Architecture Board. I was kind of confused by this presentation in that it started off explaining how what we have in terms of abstract properties that we want was insufficient in terms of our human rights documents or our privacy considerations documents. And then proceeded to say, and we have a technical solution. To me, that was a leap that you kind of lost me there. So I would say if the goal is to move forward with this technology, then I don't see a need for it at this time. I don't see any protocol that could use it. And then if that's wrong, please come back with those implementers in mind. But if the goal is to say, oh, well, maybe we need another human rights document that has these properties that we want, then yeah, that should go to HRPC, but that's not what these documents are. And just like saying, these privacy documents aren't doing anything. Well, if you look at the decade since the privacy one was published, we've done quite a few improvements to the protocols that the IETF owns in terms of privacy. So in terms of dispatch, I would say dispatch to nowhere for now until we have clear interest on what protocol should be improved specifically and what problem this solves.
Thank you. Alyssa.
Yeah, thanks. Hopefully you can hear me. Can someone confirm that you can hear me? Okay. I agree with the comments of basically everybody who came before me about the dispatch question. I didn't see anything here that seemed ready to be dispatched to someplace inside the IETF. And just wanted to note, as an author of 6973, the point of 6973 was, in fact, to just provide guidance. Like, it wasn't specifying any protocol, and it was not meant to be mandatory, and that was a conscious decision.
Could you be a little bit louder, Alyssa?
Sure. What I was saying was that it was a conscious decision to make 6973 advisory and not mandatory, because we thought that making it mandatory would just cause it to become a check the box exercise that nobody would pay attention to. And instead, I think if you look, there's actually like a good amount of evidence of how it has been used in certain cases. There's also been discussion about updating it. So if that's something that you're interested in, definitely would be interested in talking about that, because there's lots of things that have changed in the time since it was published. But it's meant to be advisory and guidance and not protocol. And I think it seems like the authors are after something different here. So I think using that as the motivator doesn't really work.
Great insight. Thank you.
Thank you. Colin Perkins.
Hi, Colin Perkins, IRTF Chair. So we are always, of course, happy to discuss proposals for new work in the IRTF, either in the particular research groups or directly come to myself or the IRSG to talk about that. As a process issue, though, I do want to remind the room that this group cannot dispatch things to the IRTF.
Noted. Thank you. Andrew Campling.
Hi, Andrew Campling. Yeah, as Alyssa just said, 6973 and in fact also 8280 are both informational RFCs from the IRTF. So maybe the authors hadn't understood what the purpose of those was, but it would be surprising if they were applied to all protocols given they're informational. So that maybe there's a misunderstanding by the two authors here. On the dispatch question, noting what Colin just said, I was about to say perhaps the IRTF would be an appropriate place to discuss the topic should the esteemed chair of the IRTF be minded to take that up afterwards.
Ted Hardy.
Ted Hardy. Thanks very much. I think the basic problem here is there are three different things being yoked together, and the fastest way to get progress here is probably to unyoke them. So if you have small scale things that relate to the work that's already going on in COSE, unyoke them from the larger scale question and go to COSE with it. If you have large scale questions of data minimization and how it affects human rights, you can talk to Colin or to the working group chairs or HRPC, but those people can't do protocol work in the IETF, just like we can't dispatch things to the IRTF. So I think you've got multiple different things kind of all put together into a vision here, but the actual work needs to be taken back out and sent to the right places, and there's no single dispatch for the whole. Some of it's just frankly out of scope for the IETF as a whole. So I just encourage you to go back and break this into the chunks of work that needs to get done, and then ask again with the individual chunks separated out, and I think the answers will be much easier. Thank you.
Do you want to summarize?
Okay, so for this work, and it seems currently it's not clear where it should go. No, I mean in IETF. So probably in IRTF, and so first to break down the work into more specific pieces, and go to the related research working groups to have more discussion and feedback there, and then maybe come back to here and have more specific feedback here.
Great. That was all very insightful. Thank you.
So next speaker, Dragana.
Here she comes.
Oh, here. You cannot control.
I think I figured out how to do slide control. So
maybe Jim can help you. You cannot.
So do you want to control the slide?
I never done it before. I asked for slides or?
No, you don't need to do anything. I just start. And
good morning. I'm Dragan Mijanovic. I'm going to talk about WebSocket extension to disable masking. Next slide. First, I'm going to explain what it is. Sorry. Thank you. So first, I'm going to talk about what it is, and why it was added, and why I think we can disable it, and how to do it. So WebSocket enables bidirectional communication between the client and the server. It starts with a handshake that is using HTTP upgrade mechanism. And after the handshake, the client and the server can send messages.
One question. Is it possible that the left side of the room also gets the slides? That would be lovely. No?
Where's the IT guys?
I don't have a way of controlling.
Out of control of the chairs.
Yeah, please. No luck. um, and so masking is the WebSocket uses frames to send the data that are sent by the application, and all the data sent from the client to the server are masked with masking key. That original payload is XORed with a masking key, so to change how it looks on the wire. And masking key is sent inside the frame header. So it's not for privacy, it's just for changing how the packets look on the wire, how the data looks on the wire. This adds extra bytes that needs to be sent for each frame, and also adds this additional processing. It's not very expensive operation, but on the server side where there is a lot of requests, this is multiplied by a lot. Why masking was added? Next slide, please. This was to protect against the attack that was described in this paper, and this picture is the original picture from the paper. Sorry for the IP addresses that are there. That was not intentional. That's from the paper. For attack to succeed, special kind of proxies, transparent caching proxies are needed that are routing the data according to the IP address, but caching the data according to the host name. And the target of the attack is actually the server who is behind this kind of proxies. So when a user accesses a website with a web resource that is controlled by attacker, this web resource can open up a WebSocket connection to the attacker.com, and after that can send arbitrary messages to the attacker. It can also construct a message that looks like HTTP request. This message will be routed to the attacker because the routing is done by IP address. And the attacker can respond with a message that looks like HTTP response, which is WebSocket message, but it looks like HTTP response. And in this case, this moment, proxy will cache this according to the host name, which is target.com. And when the next users try to get resources from target.com, it needs to be accessed using the insecure HTTP. It will hit the cache and get resources out of the cache. Next slide. So masking was added to change how the data looks on the wire, so that a client cannot construct the data that looks like HTTP request. So end-to-end encryption does the same thing, but it doesn't help in this case because the attacker controls the client and the server, so it has a key and can construct the message in the way that after encryption, it looks like plain text HTTP and can be potentially cached by these caching proxies. Next slide, please. Do we still need masking? This study that I mentioned was done in 2011. And they found 8 out of 47,000 paths that were affected with these proxies. Also, it's worth mentioning that at that time, HTTP upgrade mechanism didn't exist on the internet. It existed theoretically, but not on the internet. So these proxies didn't know how to deal with this mechanism. Now it's different. WebSockets are present everywhere. So probably most of these proxies already learn how to deal with upgrade mechanism. Also, at that time, a lot more traffic for plain text, and now they are not. So, how useful this kind of caching proxies are at this moment is also the question, and how many of them are still left. Next slide. If we look at a secure version of WebSockets that are usually sent on the port 443, or we can look at any other port than port 80, which usually gets the plain text HTTP. That will mean that this transparent proxy will listen to the connection that are usually encrypted and cache them as a plain text HTTP. Which is, considering that this caching proxies were actually caching the clear text HTTP, it's most probably they were also only listening to the port 80. It's unlikely they were listening to the other ports. Next slide. Also, for this attack to succeed, clients will need to access the website in the example before, target.com, using insecure HTTP. Considering that there is less traffic that is insecure now on the internet, or less content that is insecure on the internet now, and also it is unlikely that client will access with insecure HTTP content that is available using HTTPS, especially considering that there is a techniques like strict transport security and efforts like HTTP first. It is also less likely that the clients are going to use an insecure HTTP and hit poison cache. Next slide. Therefore, I suggest, I propose a WebSocket extension to disable masking. This extension is using WebSocket extension mechanism that is already exists, so it's just adding the new token. This is done using the HTTP headers. And I also propose adding this only to secure connections, because and excluding the port 80, because it's highly unlikely that these caching proxies are going to cache content on the encrypting port 443. Next slide. And when the extension is negotiated, the frame sent from the client to the server will not have masking key, so there will be less 4 bytes less in the header, and payload will not be masked. Frames from the server to the client will stay unchanged. Next slide. So I'm seeking interest for this work and also the working group. I started discussion on HTTP BIS mailing list because I thought that the audience is right, but it doesn't belong to their charter. So that's why I'm here. Also, I have implementation of this, and Mozilla is also having done a prototype for this draft.
Thank you. Mark Nottingham.
Hi, Mark Nottingham. So just to the trade-offs here, I think something to keep in mind is that whilst, yes, most traffic is now encrypted on the web, we still do have intercepting proxies that are intercepting TLS in enterprises, for example. And so they can still be poisoned by these techniques. Also, I think one of the other arguments you made was that most proxies have been upgraded. They've had time to learn about WebSockets upgrade. My experience in operations of networks is that proxies often are not upgraded very often. And I mean on the scale of decades sometimes. I agree that those factors do make it less likely that these attacks will succeed. I think the thing to do is to weigh it against what the costs of the changes, the cost of doing the encoding are. And as has been discussed on list, the cost is maybe not great. For the dispatch question, we asked you to bring it here because it's, as you said, it's not in our charter, although it does interact with HTTP in the sense that it's an attack on HTTP from another protocol. But if the dispatch is to take it to HTTP, I think we could talk to the ADs perhaps, and I don't know where the ADs are, but talk about maybe doing it there, because it does seem like work like this, a new working group, and unless we decide to spin up a WebSockets maintenance group, yay, that might be the sensible thing to do.
Haran.
Haran, thank you for the introduction. And based on the scenario you described, where clients need to access a website using Azure HTTPS to trigger a poisonous cache, and considering the challenge posed by the web threat adoption of HTTPS and security measures like HTS, and a relevant question might be, how can an organization ensure its website remains accessible via unsecure HTTPS without compromising security, especially in environments where a point-to-cache attack is concerned. And considering the prevalent use of HTTPS and security enhancement like HTS. By the way, this is my first time attending IETF, and I've learned a lot. Thank you.
Very good. Ecker.
Hi, yeah, we should discuss this in the list a little bit. I think this needs more motivation, frankly, before we should be thinking of doing it. That motivation would come in the form of two things. One, of demonstrating there's a substantial cost associated with the padding, with the masking, given that you're already encrypting the data and having to do AES or cha-cha. So I think likes and measurements would be helpful. The other form of measurements would be helpful would be demonstrating this is no longer an issue. I think you work for a company that has a browser, so you could take those measurements if you wanted. You could replicate the work that was done, back in 2011. But I think, saying we don't think it's an issue, but we don't know. The way we got into this hole was we didn't think it was an issue, and somebody checked. And so I think at minimum, before you remove a security feature, we should actually verify there's no longer an issue. I do want to make one small technical point, which is that the fact that you think implementations are only stooping at 80 does not necessarily help, because the attacker controls the web server, and therefore they can simply do the cache poisoning on 80 themselves with TLS. As far as I can tell, browsers will do HTTPS on 80 just fine. So that doesn't actually help you.
Okay, David Skenazy.
David Skenazy, masking enthusiast. So first, +1 to Ecker, where I think I would like to see more motivation on this, on why is masking bad. Second, to MNOT's point of sending I would recommend to send this to the WebSocket maintenance working group, which is currently called HTTP BIS. The charter of HTTP BIS seems, from my read, to allow this. So I think we should toss this can to the ADs to interpret the charter of whether WebSocket is maintained by HTTP BIS or not. As Web Transport Chair, I don't think we should have a WebSocket maintenance group, because it's not like we're doing a lot of work in WebSocket. So I would recommend taking that to HTTP, even if it might not. I would expect more motivation before I would make any progress in HTTP BIS.
Thank you. Alessandro.
Alessandro Ghedini, Cloudflare. I think an additional problem to the middle box cache poisoning thing is that there are some middle boxes that actually try to actively look at the WebSocket data and sometimes even try to inject like close frames. And I suspect that because the sort of the negotiating mechanism for the extension would be end-to-end, and because these kind of proxies tend to not be updated as often as we would like, as Mark was saying, I suspect a lot of those would probably break. How much that is a problem in practice is, I guess, to be seen. But it would be good to try and maybe do some experiments if possible before we decide to actually do this. And I also agree that with the other comments that it's not entirely clear what the benefit of not doing the masking is, but that's it.
Okay, can you summarize?
Sure. Okay, so maybe more motivations and gap analysis to show the necessary work, and also maybe go to HTTP base first to get more feedback. Okay, thank you. Next. Linja, please.
Okay, good morning, everyone. This is Lin Zhou from Zhengguanceng Laboratory. Next slide, please. This title is about the extended young data model for DAS. And here is the outline of this presentation. Let's start with the DDoS attack trends and problems. Next slide, please. Thank you. Nowadays, the DDoS attacks happens more frequently. About 8 million DDoS attacks happened in the first half year of 2023, which is 31% increase year over year. Next slide, please. And also, the DDoS attack shows the feature of hypervolumetric, the largest attack in 2023 as 200 million requests per second, almost 8 times larger than 2022 strike count. To counter this kind of randomly occurring and large-scale DDoS attack, long-term purchase and the operation of large-scale DDoS defense resources come at a very high cost. Next slide, please. And also the DDoS attacks becomes more intelligent. More than half of the DDoS attacks in 2023 is more than 2 vectors. And also this is a typical example of the intelligent DDoS attack. The fast flooding attack can suddenly spike to a high level for a short duration, which is hard to detect and also hard to defend. And also there are many new types of attacks are emerging, which are also challenges for the DDoS defense. Next slide, please. So we want to use a specific example to illustrate why we need collaborative mitigation. In this case, if there is fast flooding attack is ongoing and the attack traffic is transferred from the network of the operator to the enterprise. For the enterprise, it can detect the attacks in seconds, but because of the limited resources, it cannot mitigate the large scale DDoS attack. It needs the help of the operator. Before the operator, although it has the enough resources, but because of the sample-based detect method, it can only detect the attacks in minutes, which is very slow. So we think the enterprise and the operator should exchange the information to do the collaborative mitigation. Actually, we already have DDoS open thread signaling to do the exchange of the information. The enterprise can initiate a mitigation request to the operator, and the operator can acknowledge the attacks in minutes and develop the mitigation strategies, and then give the response to the enterprise, and then the collaborative mitigation can start. Next slide, please. But we use the DOS and find some of the problems that the data model of the DOS is not enough. For example, we want to expand the operator's visibility. The visibility means all the useful information. They can be the attack features, or the network telemetry message, or some intelligence. All these informations will help the operator to do a better mitigation strategy, and then they can use the resources, their scrubbing device or BGP full specs or something others to do the mitigation. So we think in DOS, we need a structured attack feature data model. Next slide, please. And this is the other case. If there is a slow HTTP attack is ongoing and the target needs the co-mitigation, it can there may be many servers that can offer the co-mitigation, but which one should the DOS client choose? This is a problem. So we think the client needs to know the mitigation capabilities that the server can provide in advance in order to make the right decisions. In this case, because of the slow HTTP attack is complex, it cannot be mitigated by a router with BGP flow spec. It must be mitigated by a scrubbing device. So in this case, the DOS client should choose the DOS server 1. So the client need to know the mitigation capabilities in advance to do this choice. So what we need is the mitigation capability data model, including the strategy and the capacity. Next slide, please. So here is our requirement about the extended data model. Here is the main function of the DOS signaling, including the issuing and response the mitigation requests in others. And in the three parts of it, we think they need the extended data model. Next slide, please. And we also do some work about the implementation. Here is the topology diagram of our experiment. We built an test bed to verify the mitigation effects of DDoS attacks, and also developed a simplified DDoS client and server. So in this scenario is just the same as the problem one, and in this case, we add the attack features such as the attack type and the average packet length or the duplicate message. This kind of message can help the operator find the attack in seconds with the matching with the net flow data. Next slide, please. And here is the results of the experiment with the attack features. The time to start the co-mitigation was reduced by 43%. And because of in this simulate test bed, the simulated devices have a data forwarding delay of 3 minutes. So hopefully in the real network, the co-mitigation start time can be reduced from minute level to second level. Next slide, please. This is our work. We are applying DDoS to our collaborative DDoS mitigation framework, but found some important data models that were not yet defined. So because DDoS has concluded, we want to find an appropriate working group to advance our ID. That's all. Thank you.
Okay, thank you. Zhuotao Liu.
Hi, Zhuotao from Tsinghua University. Thank you very much for your talk. I'm very interested in this part. So about maybe 20 years ago, the academic community has proposed a concept called network capability, which is a side form of cryptography, side form of routing intent to express how the network should be forwarded. And the network researchers, including myself, has published a lot of works on using this stuff to prevent DDoS attacks. But in 2018, I talked with a bunch of cloud providers like Cloudflare, like Akamai, and what they said is like, okay, we should the large providers they should only care about large things. So I'm very happy to see that from IETF that people are talking about, okay, only watching the large attacks is not enough to help the downstream customers. So I'm looking forward to how this can be unfolded in IETF in the industry. Thank you very much.
So your answer to the dispatch question?
Sorry, what do you say?
So what is your suggestion?
My comments is like I really like to see how this thing can be unfolded in IETF, because I like the feedback stuff, like from the downstream, from the victim to tell the upstream filters how they should handle their network traffic.
Yeah, thank you.
Thank you very much.
Peng Liu.
Pony from China Mobile. This topic is always important for both the operator and the enterprise network. And for China Mobile, we also have some related products in both for the public network and public cloud. I think that the proposed requirement is reasonable in your slides. It is towards to enhance the work, including extending the related protocol, considering some pre-configurations, and as well as a collaboration with mitigation strategy and the routing strategy. Since those WJ is concluded, it is better to find somewhere to promote this work. Thank you.
Okay, so next, Paul Hoffman.
To try to answer your actual question about dispatch, I believe that this should be a BOF. DOTS concluded a year ago, had lots of documents, had lots of interest. That's all being deployed. I don't think that we need a DOTS BIS yet. I don't think that much has been proposed that would do that. I would say possibly a one-time BOF for this specific draft, or for the topic of what, Now that we know that DOTS is established, how do we deal with the data that we're getting for it would be sufficient. And then hopefully an AD with the result of the BOF would be able to AD sponsor it, or to say, no, not AD sponsored, we really need a working group. But I think a BOF would be sufficient for this. Just, I haven't seen much else post DOTS in the last, I think it was like last April or whatever that it was concluded.
Okay, thank you, Paul. Kent?
Kent Watson, Chair of NetMod Working Group. We have a standing agreement to publish any Yang modules that don't fall into any other existing working groups, but we're not domain experts with DOTS. So it'd be best if you had domain experts to look at it, but as for publishing the Yang module itself, we could do it.
Thank you.
Arnold?
Yes, Arnaud Tadei, Broadcom. I would go for a buff as well from a dispatch perspective. On the content, I really don't know how you are going to have the list of the mitigations from the servers, because I don't know they are normalized. So if they're not normalized, I really don't know how it's going to work. That's it.
Okay, so the summary of dispatch would be above, and maybe not for this draft, so maybe more related topics. Okay. So you could get more feedback and during this IETF week. Okay, thank you. Next. Tim, are you ready?
Hello, can you hear me?
Yes, please start.
Oh, hi, everybody. Tim Bray here, not representing anybody. There we go. So this work came out of the IETF JSON Path working group, which is just shut down. I was co-chair, and we shipped 2 RFCs, one for iRegExp, which is a small interoperable regExp dialect, should work the same across popular libraries, and JSON Path, which has been around for ages. And in both cases, we insisted that the text be Unicode and UTF-8, and then had to consider whether that meant all of Unicode. And that question turned out to be harder to answer than we thought, and thus these drafts. Next slide, please. So most protocols and structures have data structures have text, and Unicode is good. And then the question arises, do you want to use all the characters? And the answer is no, you don't. The term code point is going to come up through this discussion, and those are just the integers that are used to identify Unicode characters, and you can see the number of them. There's a lot of them. So some of them are what we call problematic. Next slide, please. So this is the worst thing that can happen to you. So that is perfectly legal JSON per RFC 8259. So if you write a protocol and just say, well, we accept our input data in JSON, somebody could throw this at you. You can read what those things are, but in the value of the example field, there is nothing that can usefully be shown to a human, and some things that are going to cause real parsing problems. And what's going to happen is unpredictable. Some implementations of JSON parsers will return you a helpful error. Others will crash. Others will actually generate ill-formed UTF-8. Others will replace the ill-formed stuff with the little Unicode replacement character, which is the little diamond-shaped thing with the broken. Java will replace it with a question mark. It's a mess. So that's because these characters are all problematic. Let us walk through and sort them into 3 baskets. Next slide, please. So the first 2 are control codes. The old people in the room will remember what these are. These go back into ASCII days, and they're the first 32 bytes starting at 0 and 128. And they were used in sort of disgusting ways in ISO 8859 and even worse, ISO 2022. But you can't wholesale condemn them because they include new line, carriage return, and tab, which we refer to as the useful control codes, and the rest as legacy control codes. But the ones here, like 0, null, and some weird format control thing are no longer useful. Next slide. Then that DEAD there is a surrogate Surrogates are an artifact of UTF-16, which is an artifact of a period when people believed Unicode could be expressed in 16 bits, which it can't. And UTF-16 provides these surrogates to allow you to express high-value characters by pairs of surrogates. And they're only for use in UTF-16, and UTF-16 is normally not sent over the wire. So if you see these, almost certainly something has broken. This should never happen, but it does. And one of the reasons it does is because in Java, the native char data type is actually a UTF-16 code point. And if you prefix an array by taking the first 10 characters, it's real easy to end up with one of these things. So these are really problematic. They break in all sorts of ways and just should never appear. Next slide, please. Then there are some other code points that are not characters, and they're called non-characters. The history is complicated and boring, but Unicode says specifically that don't use these except in internal applications. They don't define what they mean by internal applications, but I'm pretty sure they mean not over the internet. And they can't be displayed. They have no use. So what we want to do is offer 3 subsets that in part or in whole avoid these problematic characters and thus are safer and better. So the first one, next slide please, is called Unicode scalars. And this is all the code points that aren't surrogates, and it's actually pretty widely used, not just in CBOR and IJSON, but over in the W3C, you know, the working group and things like that. They use Unicode scalars quite a lot, and they're much better than all the raw Unicode points because they exclude the surrogates, which are the most problematic, but they include all the control codes and non-characters and so on. Having said that, you know, you may end up having to use this if you are wanting to handle CBOR messages. Next slide, please. Then in 1998, XML picked this set of characters to bless, and it was the first one to point out that some of the controls were useful, but not the rest. And it gets all the surrogates. It does not get all the non-characters. And so, you know, XML may not be popular these days, but it's been around a long time and been used for a whole lot of text. And people just have not had problems that I'm aware of with character repertoires. And if you're in something like Yang, it is required to exist in both XML and JSON, you're probably stuck with this repertoire. Next slide, please. And then this is a new subset we invented for the purpose of this draft. And this is all the non-problematic code points. So it removes everything, and it's got ABNF. The ABNF here is taken straight out of the draft. The idea is that should this draft become referenceable, it would be really easy for somebody writing another draft to specify what subset they want to take up. So next slide, please. So this is not the first thing that IETF has ever thought about. This is not the first time IETF has thought about code point subsets. So there's IDNA out there, and that's about domain names. And if your text field is a domain name, we're not adding any value with unichars. Just use IDNA. Next slide, please. Then there's Précis. So there's nothing wrong with Précis, but it doesn't seem to get much visibility. And the weird thing is that I've been involved in a lot of the IETN discussions around IETF over the past years, and I'd never heard of it. So I'm not even sure how that could happen. And then in all the discussion we had with hundreds of emails on this particular draft, nobody brought it up. So it's not much. I'm not sure why. I've looked at it. I don't see anything wrong with it, but it's pretty big and complicated. Maybe people are just saying, oh, I just don't need all that stuff. I'm not sure what's going on. But in any case, there's no conflict. That you could use Précis and unichars together just fine. Next and last slide. So after we were pretty well finished with the JSON path work, we decided to write a draft that covered what we'd learned. And our EDs told us to take it to those 2 mailing lists. And we had really a good discussion with some really passionate and deep Unicode people and went through 7 drafts. And it's way, 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 way better than what we came up with in August. So big thanks to all those people who pitched in. This has received, as much discussion as some working groups give drafts of this size. It's already been referenced out there in a couple of places. I don't know. I believe that having this around to reference would be handy to creators of new drafts that have to handle text fields. They certainly would have been handy for us in JSON path. And I think it would be useful to have this exist as a standards track document in the IETF. So thank you, and we look forward to hearing suggestions as to how that might be achieved.
Do you have anything to say, Paul?
So I'm co-author, Tim was remote, I'm local, so I figured I would be the one standing here.
Okay, thanks. John Clenson.
Hi, Tim. My biggest concern is that if we end up with a large number of different profiles and ways of talking about Unicode characters and limits on them, we basically end up confusing everybody and end up with a lot of incompatibility and interoperability problems. I see your problematic characters list, but I also see some things in the ranges which you indicated are okay, which are probably problematic. And I understand your comment about pre-seed not being widely enough publicized, but it's not clear to me that making yet another competitive document would be much more widely publicized or much more widely used. So the question is, can we start with Précis and if necessary, create a new profile or discuss what the deficiencies are there? And if not, why not?
So your advice on dispatching this, John?
My advice on dispatching this is that I would like to hear from the authors why this can't be built on a Précis foundation. And if it cannot be built on a Précis foundation, then we should be discussing BOFs or working groups. If it requires modifications for Précis, we may need to start that working group up again, but I don't see this as an independent effort.
Okay, thank you. Pete.
Pete Resnick. My dispatch recommendation is ditch this document. The reason Précis exists is for folks like you to read through the requirements and register a profile. Do that. Put what you have in this document into a Précis profile, explain why it needs to be different than the existing Précis profiles. But if you need one, make one. But we don't need a working group. Précis gives you all of the instruction for how to build this. Build one. Implementers don't need to look at all the Précis documents. You do. Implementers get to look at the profile and use it. Do that.
Pete, so I have a follow-up question on that. Because it's our belief that Précis profiles have not been well used and are barely known, would that change your mind, or would you say, like you say, ditch this, and as we still won't have any focus on Précis, and therefore other groups might do things without knowing, would you, how do we get Précis profiles to be better known if we've ditched this? This as an RFC will have some focus. Précis profiles won't.
I think if you, in particular, go to the JSON community, which is what this is aimed at, and say,
one of them, yeah.
Right, here's the document that describes which things to use, Précis profile such and so. I mean, you're saying Précis profiles don't have visibility, therefore we should publish in this form that has higher visibility. Give Précis profiles visibility. Create one, point to it. Say, this is what we need to do. Great. Announce it on lots of mailing lists.
Great. Okay, thank you.
All right, thank you. Kirsten.
Thank you. I agree with Pete's dispatch verdict, but not for the same reason. A document like this should give advice. I think this gives really bad advice. It's really useful information about the history of things, so it's a good read for people who really care about the subject, and with the 7th or 8th revision, it no longer contains a lot of incorrect statements. So that already makes it a useful document in some way, but I think it really should be useful.
And the episode that Tim related to was in JSON path. We had this problem because we have JSON as our input language, and JSON accepts toxic waste. Toxic waste is something that is not Unicode, but something that a JSON parser is going to ingest and then get terrible stomachache. And Tim even had an example where one of his systems broke when that happened. So that's one thing, but then there is this weird term problematic character, and every character is problematic. A lowercase a is problematic. What you need to understand is what is your application and what do you want to do with these characters and so on. I think we really need a document that gives useful advice to people who want to define new protocols. If you want to use an old protocol, it already tells you how to do that. So SMTP tells you exactly how to operate in this space. We don't need a document for that, but we need a document for new implementers. And I think we should find some way to have such a document. I thought I might just write it quietly somewhere, but now that this document is out there as well, it's going to be the next subject in this meeting. So I'm going to shut up now.
Okay, thank you. Harold.
Harald Aldestrand. Unicode offers many opportunities to shoot yourself in the foot. This document, well, I like the presentation better than the document, because the document seems to say that as long as you're only handling code points and don't care what the code points mean, you can get away with only doing this set of rules. But it failed to acknowledge the fact that if you try to assign any kind of meaning to those code points, you get into a world of other troubles. I mean, IDNA 2008, Precis, all the string prep, name prep. We've been in this wasteland of horrors for many years. And with a significant applicability statement and a forward pointer to saying, if you try to do more than just schlep around the characters, schlep around the code points, you want to look at these other places. This could be a useful document. But I'm not sure where we should take it to get to that useful document.
That was my next question. Ori Steele.
Hi, Ori Steele, incoming Art AD. Back to the dispatch question, I heard folks saying, we wish this was a Précis profile. Précis is a working group that's not currently active. Is there a giant pool of work that needs more Précis work? In the chat, I can hear folks saying they looked at Précis and they decided not to use it in recent documents for various reasons. So I'm a bit concerned that we're sort of pinning Précis on this while we can also see evidence that folks don't want to use Précis. To the dispatch question regarding this, it seems like it's headed either for an AD sponsorship or for a new Précis working group with a whole bunch of other challenges associated with that process. And I don't like either of those options personally. Thanks.
Pete, you're.
The queue was closed, so I didn't want to just jump up. Pete Resnick. No, the nice thing about Précis is that it has this whole framework. It becomes effectively like an IANA registration. We have this framework where you can register one of these profiles. If these guys go follow it and do it, they might need some advice from the internationalization list in order to get it right. But for the most part, it's follow the directions in the document and create the profile. So no working group needed.
You want to summarize that?
Yeah. Okay, so for this draft presentation, it's a good read and provide useful advice at least a good starting point. And for the work, so people maybe more prefer to precis, although it's not popular yet. So, and also some suggestions to work more on the precis and make it more visible and yeah.
Good. Thank you.
Thank you.
Thank you.
Wow. Here?
Yeah. Thanks. I underestimated the closeness there. Thank you very much. Okay, thank you. Now, this is a really unfortunate slot because I had to pick on this other draft that actually is trying to do useful work. So I apologize for this. A while ago in 2019, I wrote a document which I think was useful at the time because I could point protocol developers to it and explain these are kind of the choices you're going to have when you are using Unicode. And this has been around for a while, and Tim's and Paul's draft kind of prompted me to dust this off a bit. Next slide, please. So obviously, this is not happening in a vacuum. We had this draft in 1969, which was called an RFC at the time, RFC 20, which we actually turned up into a IETF standard some decades later, which is ASCII. And ASCII was an externally defined document that we imported and started to use a lot in the internet. I think we can say it's built on ASCII. And well, an interesting document here, for instance, is RFC 854, which is the Telnet protocol specification. Some of you may remember Telnet. And that defined a network virtual terminal. And that's pretty much what has added the specification to ASCII as a foundational document, how we actually use it in the IETF. And then 15 years later, it became clear that ASCII is not enough. We had to do something about covering more characters, and we got an IETF policy on character sets and languages. And Harald is one of the people who made this happen. And this is BCP 18. And nobody has since questioned BCP 18. I think we all agree that UTF-8 is the way we are going to interchange a document, and the underlying Unicode is going to be our character model. And actually 5 years later, we got another internet standard, standard 63, which defined UTF-8 more precisely. This came as a sequence of several documents until it was completed. And finally, in March 2008, John, who has also been at the microphone already, co-authored a document that essentially replaced NVT, the old network virtual terminal, with one that is based on Unicode and answered a few questions that came up when you do this. So this is essentially the platform on which we stand. And the question is there anything left open here? Next slide. The problem really is, or not the problem, the opportunity, the nice thing, is that we don't need a network virtual terminal very much anymore. So we're not using Telnet that much. We are using SSH, but today we are defining protocols that have their own structure. We have XML, we have JSON, we have CBOR, we have whatever. And these already provide the structure that we use to derive from ASCII. In ASCII, you have something called record separators and unit separators. I don't know if you remember those. We actually used them in JSON sequences. But normally the structure is coming from something else like XML, JSON, CBOR representation format. So the protocol designers today use XML as or JSON or CBOR as their foundational technology, and then have to decide what kinds of Unicode strings go into these little fields, what goes into an attribute, what goes into an element, and so on. And well, at the end of at the start of the previous decade, I was helping in designing a protocol, and we ran into the problem. We needed some more text. So we actually referenced 5198, but it wasn't that useful. I mean, it still works, but it was a compromise. And as some people have said, Unicode is more complex than ASCII was. And so protocol designers really need help. Next slide. Given that this came up again in the context of another development that I'm going into called COSWID, I started writing a document and trying to get feedback on the art mailing list with some excursions to Internationalization Directorate, and also got lots of good feedback and learned a lot. Beautiful. The approach here is to have a relatively simple menu of choices that a protocol designer can make. Unfortunately, these need options because applications are different. But this is about 8 pages of document. And then I have some more 10 pages of appendices about terminology, which is really important in this space, about the history legacy issues and how we got that toxic waste into our systems. Sometimes Unicode normalization, which is relevant to many people who think it isn't relevant to them. And finally, relationship to 5198. Next slide. So the objective for this document was to be useful for protocol developers as a guide document, something they can read and don't need an afternoon for that. But also maybe as a reference that the new specification can point to and say, we are using this particular subset of Unicode. Of course, this subject could be expanded a lot. It could become a long document, but then it would become less useful for developers. So really the guide aspect is quite useful as it is. The reference aspect might require a downref in a document that uses this, or might require some standardization. So I don't have a strong opinion on this, but I think that would be useful to have as a reference mechanism. And I'm not thinking so much about formal mechanisms like PRESI profiles and so on, but simply as something that can be pointed to. And for instance, the difference between one-dimensional and two-dimensional is pretty important in many cases. So this is something that this document can be pointed to. So I could just continue developing it in quiet on my own, or we could set up something that looks at this in a more consensus-oriented way. I'm not proposing anything specific, but given the previously discussed document, I would like to hear about it.
Okay, does anyone have any opinions on dispatching this? Karsten, what in the absence of a queue, what would be your preference about how you would like to see us dispatch this?
Well, I thought I got pretty good feedback on art. So there is a certain kind of consensus that is wavering through the room, but it's not captured. And I'm mainly interested in getting a little bit more of yeah, people have looked at this and it kind of seems to be a good choice, set of choices.
Good. Well, ask for a queue and one shall appear. Go ahead, Colin.
I'm not an expert in this space, Colin Jennings. I've seen an incredible amount of time and energy spent into these problems. And my read of your document, Karsten, is that it comes to slightly different conclusions on some of the things than some of the other many working groups that have looked at this area deeply. And having yet another set of conflicting advice on this stuff will probably make the situation worse than better. So I think if we do something on this, we need to do it in a fairly serious working group type way. This is not something that an AD can just, sponsor, or that we can just do slow in some area like that. We need to be very serious about it and be willing to deprecate some, say some of the stuff we did in the past was wrong and we're going to do this instead. So.
I don't agree with that part of your statement, because I mean, we have legacy, and we will always have this legacy.
Of course.
We will still have JSON with all the toxic waste in it. We are not going to change this. This is for new designs, useful points that people can congregate on.
I understand, but its advice for new designs might be a little bit different than what some of our previously published documents would say about new design. And that's why I think this will be complicated.
Okay.
Thank you. John Clenson.
First of all, I agree with Colin about the complicated part. Our general internationalization work is in a bit of disarray, a situation which has been discussed at length with some of the relevant ADs, and we may be on track to getting some forward progress, which we have not, in my opinion, been in the last couple of years. As co-author of the document which Carsten dismissed as NVT only, that was not the intent, but that document at this point is clearly showing its age and needs some rethinking. And I wish Mike Padlipsky were here, because he was able to get far more articulate on some of these things than I can, as those of you who knew him or knew of him would know. But I think the solution for this problem, this document from a dispatching standpoint, is to look at the existing work, talk much more clearly than the drafts do now about how it relates to the existing work, integrate it with whatever the deuce we're doing with internationalization more generally, and see if it can become part of the picture rather than yet another conflicting picture, even if only partially conflicting. Because I'm very, very worried about our ending up in a situation where we've got multiple specs which are not the same, although they overlap, give people too much of a choice about where they should go or what they should look at without understanding the choices. And that's a recipe for interoperability problems, as I said before. I'm not opposed to this draft, but I think it needs to be part of a larger picture. Thanks.
Thank you. Ted Hardy.
Ted Hardy, I believe, again, you have two different things you're trying to do, and that the answer may be different for the two different things. From the guide perspective, I don't think that needs to be a standards track RFC, and in fact, it might be a better guide if it were not an RFC at all, but one where it could iterate more rapidly as experience with trying to use it for different protocol situations was learned. So I think for the guide side, I would suggest take it out of the RFC stream entirely, and then ask yourself is what is it that you want to reference as a new specification that is not itself also something that you could write up as a Précis profile. And if there's an answer to that, then I think we go back to what we just said. If there's a reference that people need that can't be a Précis profile, maybe we need to fix Précis and then make that work. If we find that we absolutely can't do that and we need a different thing, then I think this would need a working group. But I think if you split these into two pieces again, the answers sort of fall out naturally. Thank you.
Thank you.
Harold.
Harald Aldestrand again. I have some of the same objections to this draft as to the other draft, meaning that the amount of trouble you can get into is much larger than the draft seems to indicate. But comparing this one to the other drafts, they seem to come to, they are frankly incompatible. Publishing both would be a disaster. So if we want to specify something that says, here's a reasonably sane set of Unicode to use in these particular situations, we need to get one. We can't dispatch both.
Okay, that's the end of the queue. Can you summarize that?
try. Yep. So, and then this work is there are a lot of existing work, and so be careful about this overlaps with existing work, and this is also complicated new design. So. So probably for this work and the first split it and take the guide a part of it and figure out what is the new specs will be needed and then start from there. So more feedback, more discussions. Maybe
So the venue would be the ART mailing list.
Or I-18N.
Yeah, this is not really an internationalization document. I mean, it's trying to be not too wrong on internationalization, but it really is about protocol design.
Yeah.
Okay, thank you.
Okay, thank you.
Can I just interject, because Carsten just said one thing that I think is unclear, was taking it to the ART mailing list. We have two mailing lists, as both Carsten and Tim and I have pointed out. There's the ART mailing list and there's the I-18N directorate, the Internationalization Directorate mailing list. So if it's going to be dispatched to a mailing list, it would be good to know which one to dispatch it to. Thanks.
Yeah, I think Karsten said that since it's more of a protocol matter than internationalization per se, it should be dispatched to ART. Okay, we're at the end of the agenda. Thank you all for your participation and have a good week. We're about 35 minutes early. This is great.
Okay, so the summary of the dispatch outcomes will be sent after session in the mailing list, the all dispatch mailing list. Thank you.
Hi, very quickly. So Lars Eggert, AD for this session, for this BOF. We would also like to hear feedback on how this went for you as a participant. Do you like this all dispatch model of talking about potentially broad new work in this broad new group, or would you prefer something else? So please send that feedback to the ISG. Thank you.
I think that went pretty well.
Yes.
Time management.
Yeah, you see? The exact.
Yeah. The timer on the screen, I think, really helps give the speaker a lot of feedback.
Yeah, but I do take some.
That sounds great. You need to give me your number. I don't have.
Oh yeah, I also take some maybe some limited number of slides.
Yeah, there was
Make it like mandatory.
Well, maybe, yeah. I mean, there was a style thing. Different people have different styles for putting together slides.
Yes.
And the style that they used was a little atypical for IETF. It's pretty hard to say that you have to, format your slides.
Yeah, but the 40, but we do give them suggestion. They just take and also IRTS thing. And what if we have that in the future? So maybe talk with colleagues.
Well, I think kind of the way it was handled this time it's fine. We can't really formally dispatch to IRTF. We can suggest that they go and talk to Colin.
Yes.
I think that was an okay outcome.
Yeah. But I also find doesn't like
Yeah. But I mean, honestly, the fact that we were able to get the discussions in 15 minutes each, I mean, that's really that's really the thing. I don't want people going into way too much detail. It's just not useful. But still, I mean, I think we're respectful of people's time by having all of the presentations.
Jim and Shuping, are you aware that your mic is hot? Are you aware that the mic is hot?